Okay, at this point, I assume that you have read the problem and worked it on your own. Let's go over the answers. Okay, part A, this is one that people take too far at first. Says estimate V prime. Now that simply means slope. So a lot of people go ahead and do the whole tangent line, but that is not what it's asking, and you will miss points. Okay, so 16 is in between 12 and 20. Make sure you put the y's on top. So I have 240 minus 200, 20 minus 12. I end up getting 5. Now it says, doesn't say that I need units, but I'm going to give them anyway. Now it's V prime, so it's the derivative of velocity. So that'd be meters per minute squared. That's only 1 point. Now you have to show your subtraction. You can't just put the answer of 5. That won't get you any credit. Okay, part B. Using correct units, explain the meaning of this integral in the context of the problem, and then approximate that integral using a right-Riemann sum with 4 subintervals. Okay, that is straight off our Cintiq card, but the problem is you need units, units, units. Okay, so part B, the integral, my pen's not quite working, of 0 to 40, bear with me, absolute value of V of t dt is the distance Joanna travels in meters. You have to have units for 40 minutes. Okay, if you don't have the meters and you don't have the minutes, you didn't get your point. Okay, those are super important. Okay, now a lot of people get that part right, but then get this one wrong. We have to take the absolute value. A lot of people just do a straight up normal right Riemann sum. That's not going to get you any credit. Okay, so for starters, they are not the same with the part. We see it up here. We have to do them individually. So the first one is 12 wide. Its height will be on the right, which is the 200. The next one is 8 wide. Its height will be on the other one, 240 on the right. The next one is 4. And I get negative 220. This is where people mess up. Absolute value of that is 220. You have to actually take the positive 1. And then we get 16 times 150. Now this is a no calculator, so you're going to have to plug and chug. You end up getting 7,600 meters. Oh, and that part was worth 3 points. 1 point for the explanation, 1 point for the right Riemann sum, and 1 for the actual answer. Okay, so you had to have this, this, and this. All 3. Okay. Part C, we have Bob now. He's riding his bike along the same path, and we get his velocity. It says find Bob's acceleration. Well, this should be easy points right here. Acceleration is just one more derivative. So take the derivative. I get 3t squared minus 12t. Wants to know at time 5. So just watch your little errors. Plug in. I end up getting 15 meters per minute squared. Okay. And that was worth 2 points. 1 for the derivative, 1 for the answer. Okay, part D is worth 3 points. It says based on the model in part B, find his average velocity. Okay, a lot of people get this confused. I'm looking for an average. I'm not looking for an average rate of change. Don't give me f of b minus f of a all over b minus a. That is an average rate of change. It's not what I want here. I want an average of the velocity, which is 1 over b minus a to b, of the velocity. Okay, now if you do the average rate of change, you get lucky on this one because what's the inside derivative of velocity? Well, position. It might be okay. So let's go ahead. We're on interval 0 to 10. I have 1, 10 minus 0, interval 0 to 10 of t cubed minus 6t squared plus 300 dt. Don't forget your dt. Okay, so I have 1/10, and my antiderivative is 1/4 t to the 4th minus 2t cubed plus 300t, evaluate from 0 to 10. And once again, it's just a lot of plugging and chugging, okay? So if you have that and you mess up after that, just be careful on your calculations. I get 350 meters per minute. And it is a velocity, so we're still in meters per minute. And that was worth 3 points. One for the integral, one for your antiderivative, and one for your answer. Okay. So this free response shouldn't have been too bad. Now, since it's one of our first ones, it may have been pretty rough. But if we come back to this in a couple of weeks, I think you'll think it's a pretty easy one.